In Lesson 3, we'll be covering our third of 10 major topics covered in Shormann Precalculus, and that is algebra. And we'll have 3 introductory lessons on algebra. So just thinking about the general idea of algebra, we look at that photo there of Hawaiian spinner dolphins. How many are in that photo? And I mean, you could count them up or try to count them up. Anyway, maybe you won't be able to see all of them, and don't forget the baby one right there. In algebra, we use variables to represent an unknown quantity. So we might say the number of dolphins is d, or x. X is a common variable used in algebra. And as the famous mathematician Alfred North Whitehead said, the idea of variables is fundamental, both in application as well as in the theory of mathematics. So thinking about algebra a little bit more before we start in our first of 4 topics in Lesson 3 on expanding, what does algebra mean anyways? Well, in the year 830 AD, an Islamic astronomer named Muhammad ibn Musa al-Khwarizmi, I think that's how you say that, he wrote the book Hisab al-Jabr, and I'm not even going to try to say the rest of that, and means the science of transposition and cancellation. So it's a book about working with mathematical equations. So just as an example here, there's nothing special about this, but if you had 4x minus 3 equals 9, you can apply al-Jabr, add plus 3 to both sides, like that, and you end up with 4x equals 12, and we've transposed that equation to 4x equals 12. Then we can apply al-Muqabala, dividing both sides by 4. That cancels the 4 on the left, and you get x equals 12 over 4, just x equals 3. So we've transposed and canceled there to get a result for that equation. So books like al-Jabr, they're important contributions of Islamic culture. It's interesting that science and math stagnated, kind of like with the Greeks, stagnated in Islamic culture as well. And history reveals that normally science and math flourish in a service-oriented Christian culture, but stagnate in a self-centered, power-focused culture like Islam. I mean, just go to an Islamic country and just start looking around. You're going to see these images of, typically it's a man who's in power. It's like everywhere you go. It's in every building. It's like gigantic murals painted on buildings. They have a very self-centered, power-focused culture. You can understand that more deeply if you take a look at the reading assignment, but over time, algebra, that's the word that's been used instead of trying to say Hisab al-Jabr wal Muqabala instead. So today we normally think of algebra simply as arithmetic that uses variables and letters to represent numbers. That's all we're talking about here. So in Part A on expanding, and hopefully this is a review, so you can even pause the lecture if you want to, but remember the main thing you need to do are the example problems. That's what you're taking notes on mainly, and then adding any important points that you think will help you remember how to solve those types of problems, and go back to your lecture notes later to use them, and you're like, oh yeah, I need to do it this way, or remember this particular way of doing the problem. But math is best learned by doing. You can't just sit here and watch me. You have to do this yourself. Put your pencil to the paper. It's like playing a sport or learning an instrument. It just makes your brain and your body, you have to work those things together and do things. So problem A, expanding that, add like terms first. If you see like terms, like an x and a 2x, we can add those together first. And if there's just an x, that means 1x, right? So we have a 1x and a 2x. It's like saying 1 apple and 2 apples. It's not 0. There's x, we wouldn't write anything if that meant 0. So it's 1x and then 2 more x's. That means 3 x's. And so simplifying that first, we'd say 4 parentheses 3x plus y. And now we'll expand. 4 times 3x is 12x. 4 times y is 4y. Don't forget the plus that's in between them. 12x plus 4y would be the expanded form of A. And we could have had 4y plus 12x too. That doesn't matter. The order doesn't matter. in b, first we'll multiply this x by the x in x minus 5 and then by the negative 5. Then we take the 7, multiply it by the x and then by the negative 5. So that's how we'll expand these two binomials. So we'll say b, take the x times the x in x minus 5, that'd be an x squared, times it by the minus 5, that'd be a minus 5x. Move over to the 7, times it by the x, that's a 7x, positive 7x. Times it by the negative 5, 7 times negative 5 is minus 35. Add like terms to simplify. We see two like terms here, the 5x and the 7x. Negative 5 apples plus 7 apples is 2 apples, right? So x squared plus 2x minus 35. C. No like terms inside the parentheses to simplify first, so just like in B, we'll take this first term on the left, multiply it by the x, then by the 6y, then by the y squared z with a negative sign in between because there's a negative sign right there. So x squared times x is x cubed. We have to be careful with this one because there's just more terms. X squared times 6y plus 6y is 6x squared y. It doesn't matter, but I like to try to keep things in alphabetical order instead of saying y x squared, said x squared y. Minus, because of that minus sign, x squared times y squared z is x squared y squared z. Now move over to the 3xy. And so we'll have plus 3xy times x is 3x squared y. And then 3xy times 6y is plus 18xy squared minus 3xy times y squared z, which is 3xy cubed z. Now that's a lot of terms. Do you see any like terms? Well, yes, 6x squared y and 3x squared y. So we could add those two together and we'll end up with x cubed plus 9x squared y minus x squared y squared z plus 18x y squared minus 3x y cubed z. And so that's the expanded form. So we expanded that and simplified by adding like terms. Example 3.2, expand and then simplify by adding any like terms or any fractions with common denominators. So these are very similar to what we did in lesson 1 when we expanded numerical expressions, and now we'll just have variables and numbers in the expressions, but the rules for expanding and simplifying, they're the same because arithmetic is the same whether it's with numbers or with letters or combinations of those. Keep in mind too, there's a lot of ways we could write these in simplified form. So what we're going to do is consider them simplified when all the variables are written in the numerator. So you might want to make a note of that. That's how we'll simplify these in the practice sets. That's how we'll do them as well. Only numbers are going to remain in the denominator. All the variables, we'll put them in the numerator and consider that as simplified. So in the first one here, we want to expand again. And so let's just expand that out. Take the a squared k over b and multiply it by the y squared over k to start with. And so we'll have a squared k y squared over b times k. Hopefully you can see the k's are going to cancel there. And then a plus, because there's a plus sign right there, is why we're doing that. A squared k. I'm going to put the 6 out front there. Times a over b times b or b squared. So cancel. K's are going to cancel there. And that's all for canceling. Move variables to the numerator. So that means a squared b is b to the 1 power, right? So we have to move that to the numerator. That makes it a b to the minus 1, y squared, plus 6 a squared times a, that's a cubed, right? B squared, move that up, b to the minus 2k. So there's our simplified form. Let's move on to b. And notice one thing we could do first there is we could take that a squared to the 4th. We could apply the power rule to that and just make that an a to the 8th. So now we have an a to the 8th on the outside. On the inside there, notice you have a b over b cubed. That'd just be, that'd cancel that b and make that a b squared. And then if you move the x to the minus 2 up, you have a cx squared over b squared. It's like terms on the inside. Do you see that? So this actually just ends up being a to the 8th parentheses cx squared over b squared plus 3 cx squared over b squared is 4 cx squared over b squared. And that's just going to simplify to 4a to the 8th cx squared b to the minus 2. And that's it. Part B, factoring and canceling. Let's review some fundamental algebra factoring and canceling skills here. So example 3.3 says factor the following. And so when factoring, always begin by finding the greatest common factor, or GCF for short. Finding that greatest common factor and factor that out. So in A, what do we see there? We see number-wise, we see a 6 and a 12. So 6 and 12, between those two, they have a common factor of 2, right? Because they're both even numbers. But that's not the greatest common factor. 6 would be the greatest factor that they both have in common, right? So we factor that out. We see that they both have an x and a y as well, right? So 6xy is the greatest common factor. Parentheses then times 1. Why do we say 1 there? Well, because 1 times 6xy is 6xy. Minus 6 times 2 is 12y. Why do we say that? Well, expand it back out. 2y times 6xy is 12xy squared, right? So we've factored that properly. B. Do you see the 3x plus 7 there? We can think of that as one group, like a pod of dolphins or a bag of sand or a bag of rocks or something. 3x plus 7 is one group. We can factor that out, just like it was a g or a y or something. You might even want to say y equals 3x plus 7, because then you end up with a problem like this: ay plus 2by. You see the common factor there, y, parentheses, a plus 2b. Y, we're saying, is 3x plus 7, so just replace y with 3x plus 7, parentheses, a plus 2b. That's your factored form. You didn't have to do it that way. That's called a dummy variable. A dummy variable is one that doesn't really do anything. It's just replacing something else. We made a dummy variable. We said 3x plus 7 equals y. So we could think of 3x plus 7 as one thing instead of two separate things. Unity and diversity, that is everywhere present in math. Problem 4, simplify by factoring and canceling. So in A, we see 2x minus 2 over 2. The most common problem on these that students do is they just say, oh, 2 over 2, cancel, answer's 2x. No, definitely, it's not 2x. You have to, the only thing you can cancel are common factors. So in the numerator, we see 2x minus 2. We see a common factor of 2. Factor that out first. 2 parentheses x minus 1 over 2 times 1. Add a times 1 in there. So you can see now I have factors that I can cancel. 2 over 2 is the same thing as 1, right? That's why we can cancel them, because it's like multiplying by 1, right? 2 over 2 is the same thing as 1. So now we have x minus 1 over 1, which is just x minus 1. So that's the simplified form, x minus 1. B, you can't just look at that and go, oh, 6xy's cancel. The answer is 24xy squared. If you do that, you're doing a fundamental algebra 1 mistake, and this is your third year to figure this out, especially if you've done Shormann math. We talked about this in Algebra 1 a lot. We talked about it again in Algebra 2 a lot. I don't know why, but students, I don't know if it's just getting too hasty, being impatient, but year after year after year, students make this mistake. They just don't see that you have to have factors in the numerator and denominator. That's the only thing you can cancel is similar factors. So first we have to factor out a 6xy in the numerator, and that's going to be 6xy times 1 plus 4y, because 4y times 6xy is equal to 24xy squared, all over 6xy. Hopefully by now you know that's the same thing as 6xy times 1, so those will cancel. Now we're left with 1 plus 4y over 1, or just 1 plus 4y. Fundamental, super basic things in algebra, like realizing if you have x, you can write that like 1x. If you have x again, you can write that with an exponent. It's understood those ones are there. Things like that can help you understand why it's okay or not okay to cancel factors that are in the numerator and denominator. Problem 5, factor the differences of two squares. So you can apply the difference of two squares rule that's in your lesson 3 rules. And so A, you see two squares there, x squared minus y squared. The difference in those is just x plus y times x minus y. The difference of two squares, applying that rule, gives you x plus y times x minus y. You could expand that out to check it. If you do that, you're going to end up with an xy and a minus xy, which will cancel because they equal 0, and you'd get x squared minus y squared. B, 4a squared, think about that as 2a parentheses squared minus 3b parentheses squared. So we're doing 2a plus 3b times 2a minus 3b. That's the factored form. C, 25x squared. Think of 5x quantity squared minus 4 squared. So the factored form is 5x plus 4 parentheses 5x minus 4. Of course, 5x minus 4 can go first, then 5x plus 4. That doesn't matter. Just applying that difference of two squares rule, recognizing that you have the difference of two squares. That's an important part of this as well. That makes you think of the next step, what to do. Well, apply the difference of two squares rule. Look at problem 6. Factor the quadratic polynomials into two binomials. So here we're thinking about quadratic relationships of the form ax squared plus bx plus c. And so in A and B, problems A and B, those are where a is equal to 1, and that coefficient of a in ax squared is equal to 1. That's why we just have an x squared plus 9x, or an x squared minus x. So the coefficient a equals 1. When that happens, and in these example 3.6 type of problems, you can assume that these are going to factor into two binomials with integer values. And so what you do is you think of what two numbers, when multiplied together, equal c, added together equal the b coefficient. So for A, what two numbers when multiplied together equal 14? When added together equal 9? Well, that'd be a 7 and a 2, right? 7 times 2 is 14. 7 plus 2 is 9. So we can say the factored form of that is x plus 7 times x plus 2. Doesn't matter if you wrote x plus 2 then x plus 7, just that you have those two binomials. B, What two numbers multiplied together equal negative 20, added together equal a negative x, negative 1, in other words. So multiplied together, that'd be a minus 5 times 4, because minus 5 plus 4 is negative 1, right? So we'd have x minus 5, parentheses x plus 4. That's the factored form. In C, our quadratic relationship coefficient a is 2. It's not 1 anymore. So what do we do now? Well, a good first step on these is to write 2x parentheses x. Just write out your two x terms first. It's not going to be like square root 2x and square root 2x. That's not how these are designed. So you can think 2x times x, that equals 2x squared. Just think of integer values again. And now you just have to think of two coefficients so that when you expand everything out, you're going to get a negative 6 for a constant. And that's also when your x terms are going to add up to 11x. So you have to make some educated guesses. Try negative 3 and 2. Does that work? Well, expand it out. We'd have 2x squared, we'd have a minus 3x, and we'd have a plus 4x and a minus 6. Well, the minus 6 part worked, but this is just a positive 1x. It's not positive 11x. That didn't work. So it can't be that. It can't be 2x minus 3 and x plus 2. So you just have to do a little bit of trial and error here. So it could be a minus 1 and 6. And you could do this mentally as well if you want to. So think about that. Minus 1 times x, that's a negative x. 2x times 6 is 12. 12x minus x is 11x. So we can see easily that c is negative 6. It's just that x coefficient, the b coefficient, that's the harder one to see. So 2x minus 1 times x plus 6, that is correct. Problem 7, multiply or divide and factor and cancel as a first step. So we see lots of trinomials here and difference of two squares, things that we've already reviewed. So what we want to do then is just go ahead and factor and cancel as a first step like it says there. And so in A, we see that we're multiplying those two fractions together. X minus 3 times x plus 2. Difference of two squares in the denominator, so that'd be an x minus 3 times an x plus 3. Hopefully you can already see some things that are going to cancel. Times, we know for sure we need a 2x and an x. So our c coefficient is 3. So let's just think about that. If we put a plus 1 and a plus 3, that would give us an x, and a 6x is 7x. That would give us the right b coefficient as well. And then in the denominator, x squared plus 6x plus 8, x plus 4 times x plus 2. That works there. So now, I didn't need two sets of parentheses on the end there. Now let's cancel. Where can we cancel? X minus 3s are going to cancel. X plus 3s are going to cancel. X plus 2s are going to cancel. Look, we're just left with two factors in the numerator and denominator there. 2x plus 1 over x plus 4. That's how these are designed to work out. They're supposed to give you practice with factoring, but then simplifying, canceling as well. B, this time we need to multiply. We need to turn it into a multiplication problem because it's division. So that means we invert that second fraction there, this. We need to invert it and turn it into a multiplication problem. So let's do that. And let's factor first. X squared minus 36, that would be an x minus 6 times an x plus 6 over, we have a 3x parentheses x there, and think about 4 times 3, 3 times 4, 2 times 6, 6 times 2, a 3x plus 2, and an x plus 6. That works in the denominator, because you'll get a 2 times x and a 3x times 6 is 18x. That'll give you that 20x for the x coefficient there. Times, now we need to invert that. We need to flip it. So the 3x squared minus x minus 2 goes to the top. So factoring that, we'll have a 3x and an x. That's going to end up being a plus 2 and a minus 1, right? Because we have a 2x and a negative 3x. That'll give us that negative x for the x coefficient there. And then in the denominator, we're going to have x plus 5 times x minus 1. Cancel now. X minus 1's cancel there. X plus 6's cancel there. 3x plus 2's cancel there. We're left with an x minus 6 over x plus 5. And that's our simplified form. Let's move on to part C and working with exponents. And some of the following problems, they're similar to one solved in lesson 1, except these have variables and numbers instead of just numbers. So some, not all of these, are similar. So in A, what we want to do there is just simplify that. We have a cube root. So when you see that, replace the radical sign with the appropriate fractional exponent, which would be a 1/3 power. That's what all of that means, right, is to the 1/3 power. And then notice other things that are maybe to the power of 3 or to the 1/3 that may be able to cancel. So for example, like a minus 27, that's a 3 cubed, right? That's a minus 3 cubed. So we could say parentheses minus 3 cubed x to the 6th. That is to the 1/3 power. All of that is squared. Simplify that now. Minus 3 cubed times 1/3. That's like 3 times 1/3 is 3 over 3. Those exponents, applying the power rule there, that just makes that a negative 3. And then x to the 6 times 1/3, that's 6 over 3, is x squared. And then all of that is squared. Minus 3x squared times minus 3x squared is 9x to the 4th. So that's the simplified form there. Be careful on those. Just work on it a little bit at a time. We started on the inside, right? We looked at the radical sign and then the values inside that, and that's normally how these are. They're designed so that things will simplify out. So look for similarities, like the 1/3 and the 27 is 3 cubed, and how those might cancel. B, move all the variables to the numerator as a first step on that. So similar bases multiplied together, we can add the exponents, right? So we see a's in the numerator and denominator, so that would be a to the x plus 3 minus x, right? Similar bases multiplied together, we add the exponents. And then for the b bases, we have another x plus 3. Move that negative 4 up, that'd be a plus 4. So we just end up with a cubed b to the x plus 7. That's a simplified form there. Follow the directions too. It said write all variables in the numerator on that. C, it says write answer with all exponents positive. With all exponents positive. So let's start by rewriting 3x to the minus 1 as 3 over x. That makes our exponent positive. Plus y over x squared. So we could multiply, we could add these together by multiplying this by x over x, right? That way that has x squared in the denominator, and we have common denominators then, and we can say 3x plus y all over x squared. And there we go. Lastly, let's work with logarithms some more, and these won't necessarily be completely algebraic in nature, in that you'll be working mostly with numbers instead of letters as a way to review the basic laws of logarithms. But I mean, you'll see letters in there and solving for an unknown, but we'll be getting numerical answers here. So a good first step is just to write down our fundamental logarithm laws, that log base b of an argument n equals the exponent L, and n is equal to base b to the exponent L. So when you see something like a, log base 16 of n equals half, rewrite that in the exponential format. N is equal to a base of 16, an exponent of 1/2. What are you doing there? You're taking the square root of 16, right? Answer's 4. Something you should definitely know by now is that half power, the shorthand format of that is the radical sign, the square root sign. B. Log base b 36 equals 2. Write that in the exponential form. So the argument 36 is equal to base b squared. Well, 36, these are designed to simplify into simple integer values. 36 equals what squared? Well, it equals 6 squared, right? 6 squared equals b squared. So b must equal 6. And that's it. Problem 10, now we want to apply the logarithm laws found in the Lesson 3 rules. And for A, hopefully you can see you'd apply the product rule there, noting that if no base is shown, it's not like log base 1 or, how do we know what the base is? Well, if it's not written, then it's understood. There's things in algebra that are understood, right? If it's just x, it's understood that's also 1x. It's also understood it's x to the first power. If you see log, it's understood that's log base 10. So both of those are log base 10. So apply the product rule there. Log 5 times 20. That's equal to log 100. Log base 10 of 100. Log base 10 of 10 squared, right? That's equal to 2. It says don't use a calculator, but you can use a calculator if you want to check your work on it to make sure you did it right. That's actually a good idea, just to confirm that you did it right. Log of 100 on your calculator, log base 10 of 100, that equals 2. On B, log base 354 minus log base 3 of 2. So here we'll have log base 3. Apply the quotient rule this time, 54 over 2. So that's log base 3 of 27, which is log base 3 of 3 cubed, right? You just think about things. Think about the fact that these are designed to simplify. So that will also help you. Log base 3 of 3 cubed, that just equals 3. In your rules, there's also the power rule for logarithms in there, and so what that means is when you have something raised to the power, an argument raised to the power, you can put that on the outside, right? 3 log base 3 of 3. And then another rule in your logarithm laws is log base b of b equals 1. So that means this is equal to 3 times 1. So just different ways of something you actually already know or should know from what we covered in lesson 2. C, log base 4 of 1/16. So 16 is 4 squared, right? So you should recognize things like that. Understand these are designed to simplify fairly easily. So that becomes log base 4 of 1 over 4 squared, or 4 to the minus 2. Let's apply our power rule this time and have minus 2 on the outside then. Log base 4 of 4. Well, log base 4 of 4 is just 1, right? Log base b of b equals 1. Minus 2 times 1 equals minus 2. That's our answer. And that is all for lesson 3.